Let's have a look at this program. Please pause the video and try and figure out if you can see what it does. Okay, now this program is actually written in the language of C. Now in this program it's asking to start with for you to enter two integers, but before that it's actually declared the integers. Now strangely enough, int is not integer in C, it's initiate. So we need to be careful when we're looking at other code, and today we're going to be looking at pseudocode and why it's important that we have an understanding of pseudocode. Here's a second piece of code, also written in the programming language of C. You can see that three variables have been declared here, or initiated. First number, second number, as sum of the two numbers. We've got a strange line saying scanf, which is where the user is able to input their two numbers. And then again, we're adding them up and printing those values. Look at the way that these are printed though. Printf is used to print, but it uses this funny symbol using %d, and that's basically saying an integer. This is an integer. But the way it's written is remarkably different than what we're used to in Python. Again, hopefully this has emphasised the point about pseudocode. So in today's lesson we're going to be looking at the structure of pseudocode and how we use it. Let's think about the big picture. If an app development company is going to create a new game, it's going to be downloaded onto mobile devices. We've looked at the different software methodologies, but do they just jump in and start programming straight away? Well, actually the answer to that is no. You're likely to do some form of planning and assessment to start with before anything else, and that's really important. Can you think of the software development method where they do jump in and start programming? Hopefully you should have talked about extreme programming. Now, last lesson we looked at what is an algorithm, we looked at flowcharts, and today we're looking at pseudocode. Remember, this is a simplified programming code that is not language specific. This means that people can work together. Let's listen to this section about pseudocode from an industry professional. So remember, pseudocode is fake code. It actually sits partway between English and programming code. So it's language neutral. So it should be able to be read by anybody who is a programmer or who has an understanding of programming language structures. Now that means iteration, sequences, selection, subprograms, etc. Now in the exam you're going to have to understand pseudocode. This is really important for you because a lot of the exam questions are actually going to be written in pseudocode. So first of all, you'll be used to a lot of what you see on the screen. Python is quite a natural programming language, and so it's fairly simple for us to write in pseudocode. But as you saw from C at the beginning, that's significantly different, and so it's important that we understand that. Outputs would generally be the same, as would inputs. Variables would be the same, but often you declare variables, and selection. Just notice the difference between Python and pseudocode. Instead of using elifs, we expand it to else if. So elif is just a shortened version of else if. And at the end of a selection statement, we need to put end if. At the end of an if, when we usually have a colon, well, a colon in Python represents then, so we need to replace a then on the end. Now there is a different type of selection statement. We don't use these in Python, but you need to know about them. These are called the switch case statements. Now a switch case statement is used if there are several possibilities, a little bit like an if and an else. But there are numerous different programming languages which actually don't have elifs in their language. So you might have an if and an else, but not an elif. And in this case, they use a switch entry. Now, in some programming languages, you would give the criteria, followed by different cases. So we've got three cases here: case A, case B, and case C. There'd be some kind of criteria or logical check for each case, and some sort of output for that. Now you should be pretty au fait with these Boolean operators already. We have greater than or equal to, less than or equal to, equals, and the one that's slightly different is does not equal. It can sometimes be shown with either exclamation mark equals, which is not equals. Alternatively, it can be shown in the way on the screen with two of our triangular brackets. Here's a quick task. I want you to try to figure out which of these would be true or false. Here are the answers to our Boolean expressions. Did you get them all right? Now here are arithmetic operators. We've got addition, subtraction, multiplication and division. Please be careful about the language that you use. We're not using times, we're using multiplication, and add, it's addition. Now you've probably seen an exponential, the bottom one before, to the power. The ones that you might not have seen are mod and div. Now mod is the modulus and div is floor division. We know that as the quotient. Let's have a look at a few examples over the next slide. So floor division we need to know as quotient, but div comes from floor division. If we have 8 suites and 3 people, and we split those up, floor division, or the quotient, would be 2. That would mean each person would get 2 suites. If we're trying to be fair and divide them up, we'd have 2 suites each, but would actually have 2 left over. So the remainder is our modulus. So 8 mod 3 in this case would also be 2. We now have 7 suites and 2 people. So 7 suites divided by 2 would be 3. Each person would get 3 suites, so the quotient would be 3. Our modulus would be 1, there'd be 1 left over. We're assuming we can't split that suite. Our next example, 8 suites and 4 people. 8 divided by 4 is 2. They each get 2. And the modulus is 0. There are none left over. And finally, we've got 4 people, but only 3 suites. So 3 div 4, or 3 quotient 4, is actually 0. There aren't enough to go around, so nobody gets a suite. However, 3 modulus 4 would be 3. So where do we use these in Python? Well, modulus can be represented by using the percentage, and quotient can be used by 2 divisions. Now, this can be particularly useful for whose turn it is in the game. If you were to do modulus of 2 on any number, you'd either get a 1 or a 0. So 2 modulus 2 would be 0. 3 mod 2 would be 1, there's 1 left over. 4 mod 2 is 0, 5 mod 2 is 1, because there's 1 left over. So it's either a 1 or a 0. So basically this means if you keep a variable of a number, you can always figure out whose turn it is. So here's how we would do iteration in pseudocode. Almost exactly the same as we'd normally do, apart from at the bottom we'd put next I. Look at I though. I is our variable that we've used in our for loop. Now in some versions we'd put a a colon at the end, some we might not. But that next I is really important. And when we're using while as well, at the end we need to put end while. But other than that, it's pretty similar to Python. Now the one type of iteration we don't actually have in Python is a do until or a do while. Now this is different than a while loop. It always starts with a do, and you have your criteria at the end of the loop, in this case until answer equals computer. It's always going to ask or run the line of code under the do first before it reaches the until. So it only runs the criteria at the end of the loop, and it would jump back to the code, to the start, only if that criteria is met. Now this can sometimes be more useful than a while. With a while loop, you're only going to get into the while if you meet the criteria, and you're never going to run that code inside if you don't. Whereas this, you're always going to run the code at least once before you meet the criteria. Now, functions and procedures are pretty similar to what we used to. Remember that a function returns a value and a procedure doesn't. Remember though, you need end function or end procedure at the end of our function. You can see in my function example, I've set a variable to y, which equals to 777. Calls the function called triple and passes the number 7. And number 7 is passed, and that is passing by value, remember, because we're passing a direct value there, not passing by parameter. It returns that number that it's received multiplied by 3. The procedure, we've got a procedure called greeting. We still pass a value to it, and it's still passing by a value. It prints it, but it doesn't return anything. Look at the difference between the function and the procedure though. We put our value, which is returned in the function, equal to y. So 21 would be stored in y. Whereas with the procedure, we've not saved anything because there is no return from the procedure. Our arrays work in exactly the same way as you would expect an array to work with Python. So string handling works again in a similar way that we have used in Python. If we wanted the length of something, we could do .length, not len as we used to be using, because that's a very Python method. We'd have to use .length. But to get a substring, again, we could use something called a substring. So getting part of a string and returning just that part of a string. So you can see, for example, the example below, if you've got some text equal to computer science, print sumtext.length would give us 16, it's including the space, remember, and sumtext.substring 33 would be put. It's the starting position, which is P. Remember the C is at position 0, so that means O is 1, M is 2, P is 3, and we want 3 characters. So the first one, the second one, and the third one. Now comments work in exactly the same way as you would expect in Python. However, usually you'd use 2 forward slashes. You've got 2 tasks now to write in pseudocode. Look at the 2 programs and try and write them in pseudocode. Here are our answers. Hopefully you should have found that fairly simple. So you've now got a slightly longer task in pseudocode. I want you to write the pseudocode for a program that asks the user to enter the code of 2 items. It adds the cost, and if the cost is greater than 10, displays a message saying, sorry, too much. Otherwise, it displays the change due from £10. Now you're going to write the pseudocode, pass it to your friend, and they're going to convert that into Python. But your challenge is to make sure that they are able to do that, because they're going to be very picky about your pseudocode. Here's a proposed solution to our pseudocode problem. This is the next pseudocode algorithm that I'd like you to write. The algorithm is going to take a user's mark as an input and output one of the following options: a pass, merit, distinction, or fail. Look at the criteria on the screen and try and write that algorithm. You've next got some more challenging pseudocode algorithms to write. Please use the worksheet and complete each of the different algorithms. Here are the answers. I want you to take your time, work through the different answers and see if you've got them correct or incorrect. Mark your work and make improvements.